I used to make doodles like this when I was bored. I decided to write a computer program to do it for me, just because I needed an interesting project. My first decision was which tools to use. I decided on JavaScript because, for one thing, it's very easy to share the results. I'll put this URL in the description. Also, you don't need any complicated tools to create this. I'm using Chrome. Most browsers would do. And if you really want, you can even use Notepad to create these files. There's obviously a lot of other choices, but this just shows the simplicity involved. So there's a lot in here, but perhaps the question is, where do you get started? I was thinking about this. You can see each of these triangles getting split up into smaller ones, but what about the first triangle? Where do you draw that on the page? If you make this, you can obviously pick random points. You don't want to always be the same, so you could just pick 3 random points. But what if they were too close to one another, or they were all in a straight line or something? It just wouldn't be very exciting. So how do you do that? And I was out walking while I was thinking about this. I wasn't even in front of the computer. And the silliest idea came into my head. Instead of picking 3 random points, why not pick 10 random points? In fact, let's take a look at that code. So reset drawing is called every time that we run out of space or you hit refresh. And here we are. We're just making up random values, and 10 of them. In fact, I'm going to add in, I have some old debug code around here. After we draw the first triangle, why don't I show you those other points, just so you know why I'm using them. So we'll draw a blue circle. In fact, say fill instead of stroke. Save. And let's load this. So what happened? Sure, some of these were very close together. If I had randomly picked just those 3 points, that would have been a very small triangle and not very exciting. So what did we do? We picked the largest possible triangle out of all these 10 points. We picked the one with the largest volume. You know how to find the volume of a triangle with just 3 points? Neither did I, but turns out that Google does. There it is, area of a triangle. So it's amazing. You don't even have to think. Google to the rescue. So anyway, as I was walking, I was thinking about this idea. What if I had the 10 points? And by the way, it works pretty well. But when I first thought about it, it seemed ridiculously silly, because how many different combinations of 10 points can there be? And I started thinking, it's really not that bad. Even if you did it poorly, there'd only be 1,000 choices, but it's really much smaller than that, and it's, in fact, very easy to walk through this and not get any duplicates. So back to our same code here. This is right after we created the 10 random points. Well, I'm picking my first point anywhere except for the last 2 points. The rule is that the first point I grab has to come before in the array, before the other 2. It's just a way to make sure I don't have any duplicates. So here J is going to start from whatever the first point was. It's going to be a lower number. So if this was 5, then 6, 7, 8, and 9 would be available. Actually 8, 9 is reserved and can only be used for this last one. But basically we go through this list And it's just very easy. Try every combination, but without any reordering. And once I solved that problem, I realized the rest was almost trivial by comparison. That's when I decided this wasn't just a walking around and thinking about problem, but I could actually solve this. So we can see kind of what's going on here. It just picks a triangle, and then it splits it into half. Roughly, it's just a random line, and then if one gets too small, it blocks it out. So the issue is, well, the first issue is which triangle to pick. That's relatively simple. In fact, I give you a choice here. Depth first or breadth first. Here, let's make 2 copies of this so we can compare them. It automatically sizes left to right, but not top to bottom. That's a whole other issue. All right, so let's make this one breadth first, depth first, faster, faster. That's a quick way to reset them. So depth first picks one area and just keeps going into detail, almost just picking the smallest one first. Breadth first is much more spread out. Basic idea is simple. Every time we cut it in half, we first, on this one, the depth first, we finish that piece completely before we grab another. And each little piece, we focus on the little ones, and then we go back to whatever we forgot. Breadth first we cut the main triangle into 2, grab one of those and cut it into 2, grab the other one, cut it into 2. So effectively, we're grabbing one of the bigger ones each time, and we keep jumping around and moving back and forth a lot more. So it's really a matter of preference. The final result's the same. It's just a matter of how it looks while it's drawing. Really, a couple of related issues. We want these triangles to look good. Notice how some of these are really thin and you can't do much with it, where others are kind of fat. You can keep cutting them up again. So really there's 2 issues. One is, when is a triangle just too thin and you just can't work with it anymore and you have to give up? And of course we're going to color it in. Then the other thing is there something we can do to limit these so we don't just have a whole bunch of these really thin triangles? Well, I did several things to attempt to approach this problem. There's things I would have done differently, definitely, but let's start with the simplest. I said you need at least 5 pixels on every line, or else you can't break it any smaller than that. So let's say that I have a triangle here. I could draw this line anywhere, maybe, but there's going to be a limit. This side over here and this side over here both have to be more than 5 pixels. So that really just eliminates the case where you're just hugging the wall. It doesn't do as much as you would think. The problem is, on a small triangle, 5 pixels really limits you, as it should. But then you extend that triangle out, suddenly those 5 pixels get really narrow in there. But it does do at least one good thing. That 5 pixel rule, it means we're going to stop in a finite amount of time. So there's just only so many ways you can break up these lines, even if luck comes into play. There's just only so many ways, and eventually the triangle's going to have to stop. So let's say I have a triangle like this. I could go off of this wall here, or I could go off of this wall, or the third one. If I break this one somehow, it's only going to be making it narrower. Whereas if I go to one of these other walls, I can make many more of these sorts of triangles that I can keep splitting over and over. Well, one point is that you can just look at the size of the walls and say, randomly, I'm not just going to pick any point on here to start from. Now note, you only have to pick the point on the wall, because once you have that, you have to go to another point. You don't have any choices. So one of the things that I did was to say that the longer the side was, the more probability you have of picking that side, so you'd have a relatively small chance of picking that. That sounded like a good idea at first, but how about a triangle like that? These sides aren't tiny anymore. They're fairly large, so there's still a very good chance that you'll do something like this, which, in my opinion, I just want less of that. It's not as pretty. The related issue is, how do you know when to stop? How do you know that this thing has just gotten so thin that you just can't care about it anymore? And my first thought was to compare the size of the longest side versus the shortest side. But again, it misses this part here, this triangle where it's none of the sides are tiny, but the area is still getting tiny. And when I realized it wasn't the longest side versus the shortest side, it was the longest side versus the perpendicular bisector. I believe that's the right term. I should look that up. There we are. The point of that is that that tells you how much space is really in use. And you can see that this part here is somewhat small compared to this part here. And I wouldn't give up on this triangle yet, but if it was maybe half that size, I would. Well, this is more math. How do you find that perpendicular bisector? Well, it's easier than you think. This is, remember, we already know how to get the volume. That problem's been solved. Well, what's the area of a triangle? It's this segment times the perpendicular bisector divided by 2. Well, we already have the volume formula. We had that. So that's how I can look at something. I can basically ask what's the area of this triangle, divide it by the longest side, compare that to the shortest side, and decide to give up on the triangle. Let's see if we can find that code real fast. Here it is, function too thin. So it's going to be given a triangle. Triangle's just an array of 3 points. It's going to do exactly what I was just drawing. So the longest side, well, I made a length formula up here. This is just the Pythagorean theorem. So I'm looking at the length of each side. And the longest one is fairly easy to compute. Again, the area, we already have that formula. I showed that to you before. Then we have the height. And then I just ask about the ratio. It's not the ratio. It's just this minimum thing. This remember I said we wanted 5 pixels minimum. And what that means is if you have a line that's less than 10 pixels, there's no way to break it in half. So what I'm saying is if that height, if that perpendicular bisector is less than 10 pixels, it just makes no sense. There's nothing interesting you can do with the triangle. In fact, let's just go and see what we normally do with the triangle. My drawings aren't as good as my code. So we take in this triangle that we know we want to process. Again, that's just a list of 3 points. At one time, I was just totally randomly looking at which side to draw from. That's what this older code is. These comments are fairly self-explanatory, which point is which. So here is the part where I said that we were trying to give more weight based on how long each side was. So we're finding the total length of the entire triangle because that gives you the baseline, so you know each thing is a percentage of the whole. All right, so here we're saying that the random position is somewhere along the triangle, so somewhere along the total of these 3 lengths, randomly chosen. Then I said if this random number is within the size of the first thing, then we're going to split up the first thing. So we're just picking basically which point is across from the line we're going to break. And I said if not, check if it's in part of the second thing, the second line. And if not, it's part of the third one. Now we have this segment. We've picked which point and which line segment. So we went around this polygon and decided some point, some random place, and all we did with that, we said it's definitely going to be this line that we're breaking up and this point that we're going to. And that's what split 1, split 2, and shared are. So now length of broken segment. We're just taking the length of this segment here that we decide we're going to break. And then remember that we're cutting off the padding. We have these 5 pixels that you can't really use. And we didn't consider that before now. We could have, but it doesn't really matter. So we have this area here. We have to decide somewhere randomly within here we're going to have our line segment end. Again, it's going to start at this one point. Then we're going to check the triangle's too thin. We possibly could have done that sooner, but it seemed easier to do it here. If I was really worried about performance, I would have checked a little bit sooner. But either this one or this, so the distance available. Again, what if this triangle just happened to be really thin and there was still a chance of landing here? But what if that's only 9 pixels? There's just no way it could be broken. So, and I'm not even sure if that's possible after we added the too thin test. So, but that's just to be safe. So that means that there's nothing else we can do with this. We're going to change the color. You can see these. When this color gets to be the slightly darker red, that's what we're getting at. In case you don't know how to read HTML colors, that's all we're saying. This red here, these lines are the stroke, and then the triangles, the inside is the fill style. Line width of 1, the line cap just means that we have well, you can't see it quite as well since I added my debugging, but there are these sharp corners that you would see if I didn't have these blue dots. And it's real simple. We just draw that, we draw the inside part and we redraw the lines around it because otherwise it doesn't look as clean. So that's why we do the fill and the stroke. And then we exit and we return false because later sometimes people are going to care whether or not we filled it in. All right, so this is where it gets a little bit interesting, especially if you remember Dungeons and Dragons. So again, back to our picture here, we want to pick a point somewhere in this range randomly. And then I just threw in, I don't know how much difference it makes, but I decided to try to make it more toward the center. Again, I'm trying to avoid super thin triangles. That would be legal, but this would be preferable. And is there an easy way to do that? Yes. Math Random would pick any point on that line with the exact same probability. But by adding 3 of these, you suddenly get a very simplified bell curve. That's an old idea. So this just says what happens if I have 3 normal 6-sided dice. And sure enough, this is just such a common thing. Again, if you hadn't played Dungeons and Dragons, you lost out on a bunch of good math. All right, so we have where along the line we're going to break it. Then we're adding back in the padding. We had the distance between the padding and the line, but we actually want the distance from this point here to the line. So again, just little bits of math. It's all labeled nicely so you know what these things are. So again, the distance from that point, we just add the padding back in. And then a ratio here. Again, I'm just breaking this up into smaller pieces, in part for the debugger, so I can actually see it. But I'm saying this random number, I'm just scaling it. I'm saying I want to move 1/5 of the way along this line, or I want to move, this looks like more than halfway. This looks like maybe 60% of the way along that line. In fact, here's some of that debugging I was talking about. It's commented out, but was spitting out all the little details of the calculation, not just the final result, all those internal pieces. So now we're actually computing the fourth point. So there's 3 points that we're selecting up here: split 1, split 2, and shared. So we have shared is this point that's on the new on the original triangle. It's also on this top half of the triangle and the bottom half of the triangle. And then split 1 is only on the top triangle. Split 2 is only on the bottom triangle. And then shared 1 is this point right here. That's the thing we're trying to compute. We started these 3 we got very early in the process. And then we're doing a lot of work to compute this point here. And there isn't a whole lot to it. We say in the x direction, how far is this line? So we ask, what's just the x direction, this way here. In fact, why don't I try to draw that? So first you move x a little bit, and then you move y a lot. So what's this x component? Well, what we're saying is we knew the ratio is about 60%. So what was the x for the original triangle? And we're just saying that this piece here should be proportional. It's just similar triangles. Actually use this more in an upcoming project. Very important idea. So again, the x, and then the exact same thing with the y. We're just saying, how far did the y move in the original triangle? Well, just use the ratio to scale it back. And then we have these 2. Remember I said a triangle is just a list of 3 points. So it's the 2 shared points. Again, these 2 are the shared points because they're used by both new triangles. And then this is split 1, which is used by only one of the new triangles, and this is split 2 that's used by the other. This is one of the triangles, and this is the other triangle. And we push, so we had that list of triangles. I don't know if you remember when we first created that very first triangle in Reset Drawing, whenever we start a new thing. At the end here, right before our debug code, we just say that the triangles is a list that only includes that one triangle. That's right, when you first reset, you have just one. Here, let's put it down to slower. When you reset, you have just one triangle when you first start. And then each time you take one triangle off and you split it into 2 more new ones, and you add those. And that's what you're normally seeing, that it normally fills up with more and more triangles. And then how do you actually make this? We just figured out what the points were. I wasn't actually drawing anything yet. All that work was just to tell me these are the triangles. And by the way, we've already drawn everything except this one green line. So that's all we're about to do, is draw that green line. It's red on the program. I drew it green for some reason. And yeah, it's just a single thing. Go to the first point, then draw a line from there to the second point, and actually stroke the line. And again, some more debug stuff. Just when I was having trouble, I could see this in the log. And again, we returned false if we were done with the triangle. We returned true to say that there's 2 triangles. We're not using that yet. Later, we're going to make use of that. So we have another function called doOneTriangle. This previous one was just called doTriangle, and the triangle was an input. So here's a triangle, either fill it in or break it into 2. But where did that triangle come from? Well, we have this function called doOneTriangle. First thing it does, it looks for that checkbox. Remember, we looked at this. It either says depth first or breadth first. So that's this depth first or breadth first. And if it's depth first, then it grabs the last one that we added on. So depth first tries to take a recently broken triangle. This one was broken up a long time ago. It's just going to sit there. It's the most recent stuff that gets the action. Versus breadth first, where it tries to spread the action out as much as it can. So again, this has these regions that hadn't been touched because we're only looking at recent stuff. Where this, so if you say breadth first, so if depth first is false, then we call shift, which, I mean, the words are a little bit funny. You can look it up online. But this means to grab the one that I put in the longest time ago. So again, that's how you spread out the work. You say, here's some new stuff, but give me some old stuff to work on now. Here's some new stuff to work on later. Then we have do one step. So do one step. Most of the time it grabs a triangle, does something with it. But what happens if there's no more triangles? Then it resets. So here it is. If triangles length, that was the thing that we just kept adding to and taking from. So maybe when I did triangle pop, I grabbed the last one. So if the length is now 0, we call reset drawing. We already looked at that. That's where we started. That's where we added the blue dots. Basically, if there is at least one triangle, then we do the one triangle. That's the code we just looked at. And then finally, again, there is nothing like Stack Overflow in Google. I don't know how we did programming before that. But the next question is, how long do you go to sleep for? And then the simple set timeout command that says we're already in a function called do one step. Well, we're going to do the next step after, I don't know, 100 milliseconds, 10 milliseconds. Here's the choices. It's 100 milliseconds is called faster, and then so 10 times a second if you say faster, and once a second if you say slower. 1 Mississippi, 2 Mississippi. All right. So that's the basics of the program. We have a few more details. There's this resize button. I don't think I'm going to get into that. It's just a real pain in JavaScript to make something fill the entire window right. And I've done a better job when I spent more time on it, but this is a place where I actually like some of the third-party libraries just because it is such a pain to do it right. Is there anything else up here? Yeah, knit once. We're just saving a couple of things in variables just so you don't have to keep looking them up. And then that do one step we just saw. That was the thing that either drew a triangle, it broke a triangle in half, or reset the screen and drew the entire triangle. So I think that covers everything. Well, that's all the code. We do have a little more HTML. I don't know how important that is. This I just love. This does work on my phone, and it's so silly. And the default for the phone is to assume that this will be wide enough for your whole desktop. And then, since that's too wide to display on your phone, it'll cover it up, and you'll just see part of it. So you'll need your scroll bar to show you a different part of it. This line here is just magic. Again, I grabbed it off the internet. It just says, don't be stupid. If I say 100%, I mean 100% of what's visible. Fill the triangle. Fill the triangle. Then body on load. So this is where we got to the init once. There's nothing in the script that was automatically going to run. We have this thing that says where to start running, but only after the HTML is finished. Not a huge issue on this page, but sometimes it takes a while, and you just don't want to start running the program before you've finished loading the HTML page. A simple div here. You know what, some of this might be easier. Let's show this off a different way. Let's say inspect. It's a nice way to bring up the debugger. So anyway, we have this div that says everything. That ID, that allows me to do the resize trick. It's just a quick way to find, well, literally everything. Fill the triangle. That's the heading. Again, I put that in two places. It's on the page and it's on the name of the window. the canvas, of course. That's where all this drawing is taking place. Some simple buttons, radio buttons that we used. Oh, and it cleaned up. There was a bug in here, but HTML is so good at ignoring this. I should have said div followed by body. So that's all it takes. You know, I used to spend so much time doing this by hand, but now I program the computer once, and it'll do this for hours and days on end without me getting involved.